Hey everyone, welcome to Observability Landscape as Code with Terraform. Today, I'll be taking you on a little journey. First, I'll tell you a little bit about observability. Next, I'll explain what Observability Landscape as Code is all about. And finally, I'll talk about how my coworker Anna and I use Terraform to demonstrate Observability Landscape as Code in practice. And as part of that, I'll be talking about some of the Terraform gotchas that we encountered and how to fix them. But before we get started, a little bit about me. My name is Adriana Villela, and I'm a HashiCorp ambassador. I also co-host the On Call Me Maybe podcast, and I love solving hard problems, whether it's at my day job as a senior developer advocate at Lightstep, or on our walk wall, which is where you'll find me blowing off steam when I'm not at work. So now that we've gotten the pleasantries out of the way, let's get started. Now, before we can start talking about observability landscape as code, we need to understand observability. And there's no better way to understand observability than with a story. So picture this. Sandy's company has a high-profile flagship application. The development team has just deployed a couple of microservices to production. And a few hours after the deployment, the company's Twitter feed is flooded with angry tweets from users. And the anger spreads to the company's Facebook page as well. The app is acting really weird, and it's not an issue that anyone's seen before, so none of the usual alerts get triggered. Now, Sandy is on call and therefore gets paged to look at this issue. So Sandy starts troubleshooting. Now, to troubleshoot, they need to SSH into various machines to look at logs. Application logs, database logs, app server logs, transaction logs, thingamawatchet logs. If it has a log, Sandy is looking at it. Anything to give Sandy a clue as to what's causing that performance issue. Now, it takes 2 grueling and stressful hours with management breathing down Sandy's neck for much of that time. But Sandy finally connects the dots together to figure out the underlying problem. But the thing is, these types of things keep happening and it's burning them out. And same thing with their team. I mean, Sandy's too old to be dealing with this much stress this often. And honestly, this sucks. I mean, been there, done that, bought the t-shirt. It's happened to me before. It's super annoying. So obviously there's got to be a better way. It's just not sustainable. And if you guess that the better way is observability, then you are absolutely correct. So what is observability? Observability, or OLE, or O11Y for short, lets us understand a system from the outside by letting us ask questions without knowing the inner workings of that system. So what does that mean? It means that your system is emitting enough information so that you can follow the breadcrumbs to answer the question, why is this happening? So, okay, that's great. How does this help us? Well, observability has a number of benefits. First of all, it allows you to troubleshoot gnarly issues, even if you're not familiar with the code base. This is great because you don't always have to keep relying on the same go-to super senior engineers with all that domain knowledge to solve your problems. It means that now you've empowered your more junior engineers to be able to solve those icky problems as well. It also allows you to answer questions about production systems, even when you don't know what the question is ahead of time. And this is super useful because sometimes users do things in ways that are completely unpredictable. So we don't always have an inkling as to what's going on. Oh yeah, I've seen this problem. I know how to solve that. No, sometimes you've not seen the problem. You have no freaking clue what's going on. Observability gives you the information so you can follow the breadcrumbs to answer the question, why is this happening? And then finally, it allows you to identify issues in production before your users start screaming at you on social media, which is always a bonus. Now, before we continue, let's take a little detour to talk a little bit about APM, or application performance monitoring. You see, in the olden days of monoliths, APM systems were usually the accepted way of being able to monitor a system so that, if things went wrong, engineers were able to troubleshoot them relatively easily. The thing is, though, we no longer live in an age that is predominantly monoliths. We now live in the age of microservices. And with microservices, it means that you often have thousands of microservices interacting with each other in often very unpredictable ways, which means that the predictability of monoliths goes out the window, which means that APM systems are no longer suitable for dealing with production issues. But you know what is? Observability. And the bonus to that is that observability is suited for both monoliths and microservices alike. Now, as we continue to set the stage, I'm going to take you on another detour, which is OpenTelemetry. Now, OpenTelemetry is important to our narrative because with all this talk about observability, you need a way for your system to emit information to enable your engineers to follow those breadcrumbs to answer the question, why is this happening? And OpenTelemetry is just the tool to enable us to do that. So OpenTelemetry, or OTel for short, is an open source vendor neutral set of APIs and SDKs for instrumenting, generating, collecting, and exporting telemetry data. Now, why do we need such a framework? Well, in the beginning, there was no standardization, so there was chaos in the observability world as everyone was doing their own thing. Now, fortunately, OpenTelemetry, it has been embraced by all of the major observability vendors, and as a result, it has become the de facto standard for instrumenting your application code. And best of all, it is vendor neutral and open source. Now, we can't talk about OpenTelemetry without also talking about the OpenTelemetry collector. Now, the OpenTelemetry collector is a vendor neutral binary that allows us to ingest instrumentation data, whether that instrumentation comes from infrastructure or from our application. In addition, it takes the data and transforms it using processors. Now, these processors can be used to add information, so add attributes, remove attributes, or even mask your data so that you don't have to worry about sending PII data out. Now, it's all great that you're ingesting and processing this data, but the data's got to go somewhere. How do you do that? That's through exporters. Now, exporters are used to send your data out to an observability backend. And an observability backend is simply a tool that is used to render that telemetry data so that you can follow the breadcrumbs to answer the question, why is this happening? And the cool thing about exporters is that in the OpenTelemetry collector, you can use multiple exporters at the same time. So you can actually send your OTel data to more than one observability backend. Now, this isn't something that you would want to do in like a production situation, but when you're still trying to decide which observability backend best suits you, this is a great way to be able to evaluate them because you basically don't even have to change any of your code to be able to evaluate observability vendors. You just say, okay, I want to target this vendor and that vendor, and away you go. All right. So we understand observability and we know that it is all about good practices. Now, good practices are useless unless you have a consistent landscape. And the way to ensure a consistent observability landscape is through Observability-Landscape-as-Code, or OLaC for short. And we say OLaC because honestly, Observability-Landscape-as-Code is way too much to say. All right, so OLaC is the codification of observability practice of your observability landscape. And it ensures that in doing so, you have consistency, maintainability, and reproducibility. Awesome. But it still begs the question, what is an observability landscape? So your observability landscape is made up of the following components. First, we have application instrumentation. That's accomplished through, as you may have guessed, OpenTelemetry. Next, we have collecting telemetry. We collect telemetry through our good friend, the OpenTelemetry collector. And of course, our landscape wouldn't be complete without having a place to send it to, and that's our observability backend. Awesome. So these are the core components of your observability landscape. Now, there are some additional components of the observability landscape, which we won't cover too much in detail here, but I do want to mention them briefly because they are also still important. So one is meaningful service level objectives, whereby, so service level objective, or SLO, answers the question, what is the reliability goal of this service? And so an example would be number of successful requests over total requests. So say you have 1,000 requests and you want to ensure that your goal is to have 995 successful requests for that service. So that's your threshold. That's what you want to try to attain. Another example is to have a goal of latency less than 1,000 milliseconds, or high availability for your system. So 99.999% uptime. So these are things that you want to target. And then on top of SLOs as like a companion, using those SLOs to define a number of alerts for on-call engineers. So if you don't hit the threshold, or if you hit your defined threshold, where things are going totally caca, it'll call your on-call engineers, and then they'll be able to action them. All right, so now we understand observability landscape as code. Great. Now the question is, how do we go about it? And the answer is through something that we're already super familiar with, which is infrastructure as code. And more specifically, as you may have guessed, because this talk is about OLaC with Terraform, we do it through Terraform. Awesome. So now what does that look like? So ahead of KubeCon, my colleague and I put together a demonstration of OLaC in which we leveraged the OpenTelemetry demo app. Now, the OTel demo app is a great showcase of basically instrumenting a bunch of microservices written in different languages using OpenTelemetry. So these microservices are written in Java, .NET, TypeScript, Go, and Python, for example. Now, this application, we need to deploy it somewhere, so we've chosen to deploy it to a Kubernetes cluster. We also need a means of ingesting the telemetry data and then sending it somewhere. So obviously we deployed the OpenTelemetry collector, which we also deployed to Kubernetes. And finally, we want to be able to configure our observability backend, which in our case is Lightstep. Now, we did all this with Terraform. And the cool thing is, specifically about like configuring the observability backend, is that if you look at your Terraform provider registry and look up just about any observability backend out there, you will notice that pretty much all the observability backends have a Terraform provider, which is awesome because it means that you have a way of codifying the configuration of your backend. So you don't have to go clickety-click on a UI in order to be able to do stuff. And specifically what we did as part of our little showcase was create a number of dashboards in Lightstep using the using the Lightstep Terraform provider. So now that we've set the stage, the question is, what does our Terraform code look like? So first of all, I'm a huge fan of beautiful code, so we wanted to leverage Terraform modules as part of our little showcase. Secondly, as I mentioned earlier, we are deploying the OTel demo app and the OTel collector to a Kubernetes cluster. Now, it would be really sucky if we just had a demo where we assumed, okay, you have to have a cluster running somewhere and you go do your own thing. So we decided to include some code to create a Kubernetes cluster, and our cloud of choice was Google Cloud. So we created a GKE cluster in Google Cloud. And for that, we took advantage of the Google Terraform provider. Now, we also needed to deploy some Kubernetes resources to our GKE cluster. And so in order to do that, we used the Kubernetes provider. And then finally, for deploying the OTel demo app and the OTel collector, there are some existing Helm charts that were created by the OTel community. So we used the Helm provider for doing that. And of course, as I mentioned, we want to be able to configure our observability backend Lightstep. And specifically, we are creating some dashboards in Lightstep. So to do that, we used the Lightstep provider. And so our Terraform code structure looks like this. So you'll notice that we have our modules. We have 3 modules, one for creating a Kubernetes cluster, one for configuring Lightstep for creating those dashboards, and then finally one for deploying the demo app, which also included the OTel collector. Now that's all well and good, but unfortunately, the last time I touched Terraform was back in 2021, and even that, I'd never written any Terraform code from scratch myself. So cue in the panic because I ran into some really nasty gotchas as part of putting this demo together. And I'm going to spend the next little bit highlighting 3 of the gotchas that we ran into and how we fix them in order to spare you some grief in the future. All right, so gotcha number 1, what I like to call the chicken and egg problem. So here's the deal. As I mentioned, we are creating a Kubernetes cluster, and afterwards we're deploying the OTel demo app and the OTel collector. But in order to do that, we need information about our Kubernetes cluster in order to know which cluster to deploy it to. So we use the Terraform data stanza, which collects information about our Kubernetes cluster, and we reference the data stanza in our Kubernetes provider and our Helm provider configurations. Awesome. So with that in mind, we hit Terraform apply and ran into these lovely errors. So we have invalid template interpolation value and 3 attempt to index null value, which was super, super stressful. Like, I had no idea where this stuff was coming from. And so I did some Googling, and it turns out, well, it's actually quite obvious. Terraform does not care about the order in which things are executed. It doesn't know that I need to have my Kubernetes cluster in place before I can deploy my Helm charts, before I can create resources on my Kubernetes cluster. So when I hit Terraform apply, it's like, hey, this data stanza is empty because you don't have a Kubernetes cluster. And I'm like, of course not, you haven't created a Kubernetes cluster. So what we need to do is force Terraform to only try to read the data stanza once the Kubernetes cluster has been created. And we do this by adding the depends on attribute to our data stanza. And in doing so, made the error go away, and all was well with the world until the next problem. Gotcha number 2, using modules and depends on. So as I mentioned earlier, we use modules for our Terraform code, but of course, when we started, we just had one big hunk of code, and then we started putting it up. And once we started organizing things into modules, we just thought, okay, well, we'll just do a lift and shift, move all the module specific stuff into the modules, and we're all good. And here is how we called our modules. So we have my Kubernetes creation cluster module first. Then we have the deploy OTel demo app and Lightstep dashboards modules, which get called next. And they're dependent on the Kubernetes cluster create module. Awesome. I'm like, yeah, I'm on a roll of modules. Woohoo, I got this nailed. Except then I ran Terraform apply and ran into this issue. Module is incompatible with count for each and depends on. And I'm like, wait, Terraform, are you saying that I can't use depends on with my modules? Like, this seems bananas to me. Well, it turns out that if I want to be able to use depends on with my modules in this case, what I have to do is I have to ensure that my provider configurations are actually located not in the child module, which is what I was doing, but I have to move them over to the root modules. So these configurations are perfectly fine as long as they're not in the child module. So once I move them out of the child module into the root module, all was well. Because the thing is, Terraform, when you configure your providers in the root module, it just passes those configurations down to the child modules, so you don't have to worry about it. All good. Great, so made that fix, all was well with the world. Terraform was no longer mad at me until I hit gotcha number 3, referencing a partner provider from a module. Now, this one, I would have to say, was the most confusing of the gotchas that we encountered. So let me explain what happened. Now, you might recall that I mentioned earlier that in order to configure the Lightstep dashboards, we are using the Lightstep provider. Now, the Lightstep provider is what's known as a partner provider, which means that it is created and maintained by Lightstep. So the first part of the name here, Lightstep, says created and maintained by Lightstep. The second part of the name here, Lightstep, means that it's called Lightstep. Great. So I ran Terraform init and then got this error. Failed to query available provider packages. And I'm like, okay, this is confusing. And then reading it further, could not retrieve the list of available versions for provider HashiCorp Lightstep. And I'm like doing a double take. I'm like, what are you talking about? Because clearly this says that it's Lightstep. So why are you coming up with this HashiCorp Lightstep nonsense? Well, after much Googling, much confusion, it turns out that when you are using a provider in a module, Terraform assumes that the provider name is prefixed with HashiCorp instead of what the partner provider actually is. So in order to make that error go away, you have to add a required providers stanza to your child module as well. So basically, we've got the required providers in our root module that has all of our required providers. And then in our child module that's using the Lightstep provider, I have to include a required provider stanza that specifies, yes, I am in fact using the Lightstep provider. And in doing so, was able to run Terraform init. Error's gone away. All is well with the world. Huge sigh of relief. And congratulations, we have achieved observability landscape as code. Hooray! Now, before I wrap up, I do want to mention one final thing. So as I said earlier, we have tackled the first three aspects of OLaC, which is application instrumentation, collecting telemetry, and observability backend. We have codified that. Now, the last two parts, so defining SLOs and alerts for on-call engineers, these parts still need to be done. And so my call to action to you is, if you are at all interested in OLaC, please reach out. I would love to do a collaboration with you to see how we can POC these other aspects of OLaC. There are a couple of options already for codifying SLOs. For example, there is something called OpenSLO. Now, it hasn't become a standard, but perhaps it might become a standard at some point in the future. So that might be an interesting thing to play around with. Also, some observability vendors have, they codify their SLOs as part of their own providers. So that's another interesting thing that could be fun to play with. And then integrating the codification of alerts for on-call engineers with some sort of incident response, incident management system, I think could be a really cool thing as well in the future for OLaC. Now, I want to wrap up by providing you with a list of resources that were discussed in this presentation. So first of all, we've got the GitHub demo app, the GitHub repo for the OTel demo app. We've got the GitHub repo for the OTel demo app Helm chart. We've got a repo for our Terraform code for the OLaC example that I described today. And I've also got companion blog posts for OLaC in practice and the 3 Terraform issues that I described today. And finally, please do check out the On Call Me Maybe podcast. I highly encourage you to give it a listen. It is lots and lots of fun. We have all sorts of really interesting guests on there. Thank you so much for sticking around. Really appreciate it. Hopefully you learned some really awesome things about observability and OLaC and Terraform. Please don't hesitate to connect through Mastodon, LinkedIn, and Twitter. And of course, don't forget to follow and subscribe on Call Me Maybe. Thank you again. Signing off with peace, love, and code.